Welcome to this report on one of the biggest mysteries in the universe, dark matter and dark energy. These two substances make up the majority of the matter and energy in the universe, yet we still know very little about them. In this report, we'll explore what we know about dark matter and dark energy, the evidence that supports their existence, and the ongoing efforts to learn more about them. We'll also ask some of the biggest questions surrounding these mysterious substances, and attempt to answer them using the latest scientific research. So buckle up and prepare to journey into the unknown as we delve into the fascinating world of dark matter and dark energy. Certainly. Dark matter and dark energy are two of the biggest mysteries in the universe, and scientists have been working for decades to better understand these mysterious substances. In this report, we'll explore what we know about dark matter and dark energy, the evidence that supports their existence, and the ongoing efforts to learn more about them. What is dark matter? Dark matter is a mysterious substance that makes up about 85% of the matter in the universe. It is called dark because it does not emit, absorb, or reflect light or other forms of electromagnetic radiation. This makes it invisible to telescopes and other instruments that rely on light to detect objects in the universe. Despite being invisible, scientists have been able to infer the existence of dark matter through its gravitational effects on visible matter. For example, the way that galaxies rotate and cluster together cannot be explained by the gravitational pull of visible matter alone. Instead, scientists hypothesize that dark matter must be present, exerting its own gravitational pull and holding galaxies together. There are several theories about what dark matter could be made of. One of the leading theories is that dark matter is made up of weakly interacting massive particles, WIMPs, which are particles that do not interact with light or other forms of electromagnetic radiation but do interact weakly with ordinary matter. Other theories propose that dark matter is made up of subatomic particles that have not yet been discovered. What is dark energy? Dark energy is another mysterious substance that makes up about 68% of the total energy in the universe. Unlike dark matter, which exerts a gravitational pull, dark energy has a repulsive effect on the universe, causing it to expand at an accelerating rate. The existence of dark energy was first proposed in the late 1990s, based on observations of distant supernovae. These observations showed that the rate of expansion of the universe was not slowing down, as scientists had previously believed, but was in fact accelerating. Like dark matter, the nature of dark energy is not well understood. One theory is that dark energy is a property of space itself, known as the cosmological constant. Another theory is that dark energy is related to the vacuum energy of the universe, which is the energy that exists in empty space. What is the evidence for dark matter and dark energy? The evidence for dark matter and dark energy comes from a variety of sources. For dark matter, the strongest evidence comes from observations of the rotation of galaxies, which cannot be explained by the gravitational pull of visible matter alone. Other evidence comes from the way that galaxies cluster together and the gravitational lensing of light by massive objects. The evidence for dark energy comes from observations of distant supernovae, as well as measurements of the cosmic microwave background radiation and the large-scale structure of the universe. These observations all point to an accelerating expansion of the universe, which can only be explained by the presence of dark energy. What are scientists doing to learn more about dark matter and dark energy? Scientists are using a variety of methods to study dark matter and dark energy. One approach is to look for direct evidence of dark matter by searching for WIMPs or other subatomic particles that could make up dark matter. Several experiments, including the Large Hadron Collider and the Dark Energy Survey, are dedicated to this task. Another approach is to study the gravitational effects of dark matter and dark energy on visible matter. For example, scientists can observe the way that light is bent by the gravitational lensing of dark matter, or study the way that galaxies cluster together to infer the presence of dark matter. There are also ongoing efforts to understand the nature of dark energy, including experiments that study the cosmic microwave background radiation and the large-scale structure of the universe. One of the most interesting aspects of dark matter and dark energy is that they are completely invisible to us. We cannot see, touch, or interact with them in any way. However, scientists have been able to infer their existence through their effects on visible matter in the universe. For example, as we mentioned earlier, dark matter exerts a gravitational pull on visible matter, such as stars and galaxies. This can be observed in the way that galaxies rotate and cluster together. In fact, without the presence of dark matter, galaxies would not be able to hold together and would fly apart due to the centrifugal force caused by their rotation. Similarly, dark energy's effect on the universe can be observed through its impact on the expansion of the universe. Scientists have measured the rate of expansion of the universe over time and have found that it is accelerating. This can only be explained by the presence of dark energy, which is causing the universe to expand at an ever-increasing rate. Another interesting aspect of dark matter and dark energy is that they may be connected in some way. Some theories propose that dark energy is actually a property of dark matter, and that the two substances are intimately linked. However, despite decades of research, we still know very little about the true nature of dark matter and dark energy. Scientists are continuing to study these mysterious substances using a variety of methods, including particle accelerators, telescopes, and simulations. One of the biggest questions surrounding dark matter and dark energy is whether they have any implications for the ultimate fate of the universe. Some theories propose that dark energy will cause the universe to expand at an ever-increasing rate until eventually all matter is torn apart. Others suggest that dark matter will eventually clump together and form massive structures, such as dark matter galaxies. Overall, dark matter and dark energy are two of the most fascinating and mysterious substances in the universe. As our understanding of these substances continues to grow, we may be able to unlock some of the deepest secrets of the cosmos. Dark matter and dark energy have been the focus of intense scientific study for many decades, with researchers around the world seeking to unravel the mysteries of these enigmatic substances. Some of the most notable contributions to our understanding of dark matter and dark energy have come from scientists such as Vera Rubin, who provided some of the earliest evidence for the existence of dark matter in the 1970s, and Fritz Zwicky, who first proposed the concept of dark matter in the 1930s. More recently, astrophysicists Saul Perlmutter, Brian Schmidt, and Adam Rees were awarded the Nobel Prize in Physics in 2011 for their discovery that the expansion of the universe is accelerating, while James Peebles was awarded the Nobel Prize in Physics in 2019 for his contributions to our understanding of the structure and evolution of the universe. Thanks to the tireless efforts of these and many other scientists, we have made great strides in understanding dark matter and dark energy, but there is still much more to learn about these fascinating substances that make up the majority of the universe. What are the potential implications of dark matter and dark energy for the fate of the universe? Dark matter and dark energy could potentially determine the ultimate fate of the universe. While dark matter provides the gravitational pull necessary to hold galaxies together, dark energy is thought to be responsible for the accelerating expansion of the universe. Depending on the amount of dark matter and dark energy present, the universe could either continue to expand forever or eventually collapse back in on itself. How do dark matter and dark energy relate to other major topics in physics, such as relativity, quantum mechanics, and the nature of space and time? Dark matter and dark energy are related to other major topics in physics such as relativity and quantum mechanics in various ways. In terms of relativity, dark matter and dark energy are related to the gravitational force. According to the theory of general relativity, gravity is the curvature of spacetime caused by mass and energy. Dark matter is believed to make up a significant portion of the total mass in the universe, which means it has a gravitational effect on other matter and affects the curvature of spacetime. Dark energy, on the other hand, is believed to be responsible for the acceleration of the expansion of the universe. In terms of quantum mechanics, dark matter and dark energy are related to the fundamental nature of matter and energy. Dark matter is thought to consist of particles that do not interact with light or other electromagnetic radiation, making them invisible to telescopes and difficult to detect directly. Studying the properties of dark matter particles could shed light on the properties of matter and energy at the most fundamental level. Dark energy, meanwhile, is believed to be a property of spacetime itself and could be related to the vacuum energy predicted by quantum field theory. Overall, dark matter and dark energy are important topics in physics that are intimately connected to other major areas of study, including relativity and quantum mechanics. While much remains unknown about these mysterious substances, continued research and investigation could help us unlock some of the deepest secrets of the universe. Could there be other forms of dark matter and dark energy that we haven't discovered yet? The possibility of other forms of dark matter and dark energy beyond what we currently know is an active area of research in astrophysics and cosmology. One reason for this is that the existing theories and observations of dark matter and dark energy leave some questions unanswered. For example, the nature and properties of dark matter particles are still largely unknown, and it is possible that there are other types of particles that could also contribute to the overall mass of the universe. Similarly, while dark energy is currently thought to be a cosmological constant, it is possible that it is a dynamic field that changes over time. Therefore, scientists continue to search for new clues and phenomena that could shed light on the true nature of dark matter and dark energy, and whether there are additional forms that we haven't yet discovered. What is the relationship between dark matter and black holes? The relationship between dark matter and black holes is an active area of research in astrophysics. While black holes themselves do not emit light, the effects of their gravity on surrounding matter can provide clues about the distribution and properties of dark matter in their vicinity. In particular, scientists have observed that the motion of stars and gas around black holes can reveal the presence of dark matter, which has a gravitational effect on these objects. Additionally, some theories suggest that black holes could be a source of dark matter, either through the decay or annihilation of primordial black holes, or through the creation of dark matter particles in the extreme conditions near a black hole's event horizon. Therefore, studying the relationship between dark matter and black holes can provide important insights into both the nature of dark matter and the behavior of black holes, two of the most mysterious and intriguing phenomena in the universe. Could there be a connection between dark matter and the observed excess of matter over antimatter in the universe? The observed excess of matter over antimatter in the universe is a long-standing mystery in physics. While the standard model of particle physics predicts equal amounts of matter and antimatter should have been created during the Big Bang, observations indicate a significant imbalance in favor of matter. The baryon asymmetry problem arises from the fact that the Big Bang should have produced equal amounts of matter and antimatter, yet we observe a universe that is made almost entirely of matter. This has puzzled physicists for decades, and several theories have been proposed to explain the observed baryon asymmetry. One popular explanation is known as leptogenesis, which suggests that the decay of heavy particles in the early universe created a slight excess of matter over antimatter. However, this explanation is not yet fully understood and remains an area of active research. One possible explanation for this asymmetry is that dark matter could have played a role in tipping the scales in favor of matter. Some theories propose that dark matter particles and their antiparticles could have interacted differently during the early universe, leading to a slight excess of matter over antimatter that was amplified by subsequent cosmic evolution. While this connection between dark matter and the matter-antimatter asymmetry is still speculative and requires further investigation, it offers an intriguing possibility for understanding one of the fundamental puzzles of the universe. The baryon asymmetry problem arises from the fact that the Big Bang should have produced equal amounts of matter and antimatter, yet we observe a universe that is made almost entirely of matter. This has puzzled physicists for decades, and several theories have been proposed to explain the observed baryon asymmetry. One popular explanation is known as leptogenesis, which suggests that the decay of heavy particles in the early universe created a slight excess of matter over antimatter. However, this explanation is not yet fully understood and remains an area of active research. Thank you for tuning in to Culture Clubhouse, where we explore some of the most fascinating mysteries of the universe. In this video, we dove into the captivating topics of dark matter and dark energy, discussing what they are, how they were discovered, and what implications they have for our understanding of the universe. We hope you found this discussion informative and thought-provoking. If you enjoyed this video, please consider sharing it with your friends and family, subscribing to our channel, and leaving a like or a comment below. Your support helps us continue to create engaging content and explore the wonders of the cosmos. Thank you for being a part of the Culture Clubhouse community, and we look forward to bringing you more exciting content in the future.